trigonometry, and developing and applying the sine law. To develop the sine law, you need to draw any non-right triangle ABC. Then draw a perpendicular line from vertex B to side AC and label the perpendicular line H. State the sine ratios for angle A and angle C, and then attempt to create an equation that relates the two sine ratios. Pause the video now and do this before moving on. So you should have drawn a triangle that looks like the one I've got on the page here, ABC, and your perpendicular line should have gone from vertex B straight down to side B, or side AC. Remember, it cuts it at a 90-degree angle, or it crosses AC at a 90-degree angle, but it doesn't necessarily cut it in half. Now when we look at this next, we can find the sine ratios. If I look at sine of angle A, I've created a right triangle, and sine A is opposite, which is H, over hypotenuse, which is C. When I look at the other side of the triangle, I have another right triangle, and I can say sine C equals side H over side A. So when I look at them, both of those equations have an H in them. So if I rearrange sine A equals H over C, that becomes H equals C sine A. And when I rearrange sine C equals H over A, it becomes A sine C. So now, if I look at that, they're both equal to H, which makes sense because the height's the same in both triangles. I can set the two equations equal to one another. Okay, now I can divide both sides by AC, as I did here on the left. And if I look at that, I end up with sine A over A equals sine C over C. Or on the right here, you can see I divided both sides by sine A sine C, and I can write it as A over sine A equals C over sine C. Now the only thing I don't have in this equation is a relationship with side B and angle B. If I went back to my diagram and drew my perpendicular from angle A to side BC, I could create a similar relationship. And I would end up with C sine B equals B sine A, which could result in sine B over B equals sine C over C. And when I do that, if I look back, I know that sine C over C is also equal to sine A over A. So I can conclude that sine A over A equals sine B over B, which is also equal to sine C over C. This is what's known as the sine law. It doesn't matter whether you put your sine ratios in the numerator or in the denominator, as long as they are always in the same space. The other thing that's important is if this is angle A, it better be side A in the denominator. Similarly, angle B in the numerator, side B in the denominator, and so on. So what do you think we have to know in order to solve for an unknown in the sine law? If I look back at a picture, I know sine A over A is sine B over B. If I look at this, if I know sine A, if I know angle A and I know angle B, then as long as I know side A or side B, I can solve for the other one. So that would mean somewhere along the way, I'm going to have to know a complete pair in order to solve. I only want to have one piece of missing information. If I have two angles, even if I have side C, I'll be able to have a complete ratio because I know the angles in a triangle add to 180 degrees. So I can figure out what C is by subtracting angle A and angle B. Otherwise, I need to have an angle and the side opposite and any other side. I could have side B or I could have side C. And that's what this is all here. So to recap, the sine law can be used when you have two sides and the angle opposite one of the given sides, or one side and any two angles. So if we want to solve triangle ABC, correct to one decimal place, if angle A is 40, B is 74, and A is 5, I need to start by drawing a diagram. I've got angle A, angle B, and angle C. And angle A I said was 40 degrees, and B is 74 degrees, and side A, which is opposite angle A, is 5 centimeters. It said solve, so I'm looking for all of the missing pieces of the puzzle. Now the first thing I know is that angle C is going to be 180 minus 40 degrees minus 74 degrees. So that means angle C is, now in order to solve this proportion, we're going to start with one pair of ratios. So we'll start with side B. So we can write 5 over sine 40 is B over sine 74. And as we do that, we can follow our steps. We can multiply both sides by sine 40. Multiply both sides by sine 40 and sine 74. So we end up with, in essence, we're cross multiplying. Because when we multiply both sides by sine 40 and the sine 74, we see that what happens is the B ends up being multiplied with sine 40 and the 5 ends up being multiplied with the sine 74. And we can divide both sides by the sine of 40. Now I haven't done any calculations till the very last step here in order to eliminate rounding errors. And I see that B is equal to 7.5 centimeters approximately. And when I do the second one, again, I'm going to multiply both sides in this second proportion. I'm multiplying both sides by sine 66 and sine 74, and once I do some reducing, I'm left with C sine 40 is 5 sine 66, and to get C by itself, I divide both sides by sine 40. Again, wait till the last step to do your calculations to avoid rounding errors. Now once I solved for my last side, or my second side in the triangle, could I use Pythagorean theorem? Hopefully you've said no, because we didn't have a right triangle.